Hello, welcome to today's video where I'm going to be showing you how to multiply out brackets more quickly like a pro for situations where there's a power applied to the brackets. And we're going to do this using a trick called binomial expansion. However, before we begin, I must warn you that I'm assuming that you've already seen my previous video on this topic where I showed the link between something called NCR and what goes on when you manually multiply out brackets. So if you haven't taken a look at that video or you don't know what I'm talking about, then do watch that video, and a link to that video is appearing on the screen right now. But with that out of the way, what are we doing? Well, as I mentioned, we're going to be using a trick called binomial expansion, which is only for situations where you're trying to multiply out brackets that have a power applied to them. But to see how this trick is going to work, let's take a look at what happens when you do try to manually multiply out brackets. Let's say we're taking a look at the example where you've got a plus b all to the power of 2, and we're trying to expand that. Well, first thing to realize is, of course, that the power of 2 means that secretly we're doing a plus b times by a plus b. And therefore, if we want to multiply those brackets, we're going to have to try all the combinations of the things inside the first pair of brackets multiplied by the things inside the second pair of brackets. So going through that, we first would have a times by a, which would be a squared. We'd have the a in the first bracket times by the b in the second brackets. So therefore, that would get us a ab. But then we also have a b in the first bracket times by the a in the second bracket, which means we have another ab, so we've got a total of 2ab overall. And then lastly we have b times by b, which would be b squared. Okay, that's what we get when we multiply out the brackets, but why do we care about this? Why is this interesting? Well, let's take a look at the individual parts we got. First of all, let's look at what happens to the a in our answer. You'll notice in the first term we got from doing the expansion, we got an a to the power of 2. But then as you progress through the other terms, you'll notice there still is an a involved, but the power of a decreases as we go along, because in the second term we've got an a, but it's now only just an a, secretly an a to the power of 1 if you will. And then by the time you get to the third term, it looks like there's no a involved at all. And that is because in reality, there sort of is an a involved, but it's secretly an a to the power of 0. Because of course, anything to the power of 0 is 1, so therefore we're doing b squared times by 1, which is of course the b squared we saw before. The point I'm making though is we started off with a squared, and every time we progressed one term to the right, the power of a decreased by 1. Similarly, if we now look at what happens to the b's, we realise that in the first term we have no b's at all, but again that could be viewed as us secretly having b to the power of 0. And then in the second term we've got b to the power of 1, and in the third term we've got b squared. So therefore what was happening to the b? Well, instead of starting at a high power and working down, like what happened with the a's, we're starting off with b as being a power of 0, and then we're increasing the power by 1 every time we go one term to the right. So what you'll notice is we've got this sort of seesaw effect going on where one of the terms' powers is decreasing while the other term's power increase. But is this a coincidence that's just happening with a plus b to the power of 2? Well, no. If you do a plus b to the power of 3 and manually try to expand that out yourself, you'll get the following thing that you can see on the screen, and once again you can see that a cubed becomes a squared, becomes a to the power of 1, becomes no a's at all on the end, and then also we had no b's, then we have b to the power of 1, then b to the power of 2, then b to the power of 3. So this pattern does continue on. But then the other thing you might notice is that sometimes we have a number in front of the algebra. We have no number in front of the a squared, no number in front of the b squared, going back to this example up here, but then we do have a 2 in front of the middle term. This is then harking back to that NCR stuff I was talking about in the previous video. So the third part of the expansion, the third thing playing a role, is that coefficient obtained from doing NCR. So therefore, overall, summarizing what we've just pointed out, when you expand brackets with a power to do binomial expansion, all you've got to realize is that one of the things inside the original brackets starts at the highest power it possibly could have, which is the same power that the original brackets would have. And then as you progress through the terms, the power of that thing will decrease by 1 every single time. Meanwhile, the other thing that was inside the original brackets will start at a power of 0 for the first term, and then you will increase the power of that thing by 1 every time you progress through the terms. And then the last thing that contributes to the terms of the expansion is the NCR stuff we were talking about before. Crucially, the n in NCR matches the power of the original brackets, and then the r matches the power of either the a part or the b part in each term. Okay, so that's me describing in words the steps you need to do, but as you can see from how much I had to write on the screen to do that, describing maths in words is always more horrible than often actually doing the maths itself. So let's do an example, because when we do the example, hopefully you'll see what's really going on when we do that. And to do this example, I'm going to set out my work using a table. You don't have to set out your work in the same way that I do, and in fact I will show an alternative way you could set out your work if you don't like using the table, but I quite like the table because it provides some structure to what we're doing. So the table we're going to be using will have 3 columns, because each of these columns is going to be devoted to one of those parts we're talking about before, either the A part, or the B part, or the NCR part. So, with that said, let's start off with the A part. Now technically, if you want to get really technical, the A is going to be taken to the power of n minus r. But put more simply, what you're going to do is you're going to start off by deciding what your A thing is. So I'm going to decide that my number 2 is my A. And what you're going to do is you're going to start off with taking that A to the maximum power it can be, which is the power of the brackets, which is your value of n for later. So therefore, I'm going to start by taking 2 to the power of 5, and then as I progress through the terms, we're going to take it to a smaller and smaller power, all the way until we get to 2 to the power of 0. Once you get to that thing to the power of 0, that's when you know you're done with dealing with that thing. And then at the same time as that's happening, what's happening is we've also got powers being applied to the other thing inside the brackets, which I'm going to call my b. Now, the b is always being taken to technically the power of r. But in more simple terms, what I'm saying is, as the a term started at the maximum power, the b term has to start at the minimum power, which would be 0. So therefore, I'm going to start by taking 3x to the power of 0. I'm being very careful to write the 3x inside the brackets before the power is being applied to it, because the power is meant to be affecting both the 3 and the x. But anyway, therefore then as we progress through the terms, the power of this thing is going to increase by 1 every single time. So therefore, this is what's happening to the 3x for each term. And by the way, something else you can use to help check as you go along is the powers of both the a and the b term must always add up to the power of the brackets, the value of n. So you'll notice for each row, the power of a and the power of b in this table adds up to 5, as for my example, the brackets were being taken to the power of 5. So we're 2/3 of the way there. There's just one more part of the expansion we need to consider, which is the NCR part. And the way we deal with that is realize that the n is just the power of the brackets, so each of these things are going to be 5c something, but then the r is going to be decided by basically the power of either the a or the b that we've used in this table. So I often like to make the r follow the power of the b, but it really doesn't matter. NCR is symmetrical, so you'll get the same values out either way. But therefore I'm going to say 5c0, 5c1, 5c2, 5c3, 5c4, and 5c5. Okay, so these are the parts that make up each term in the expansion, but now we need to actually find them, but then once we've found them, we then also need to multiply the things together in each row, because each of these 3 parts multiplied together form each term in the expansion. So therefore, I'm going to do 2 to the power of 5, and that would be 32. 3x to the power of 0 is just 1, and then 5c0 is also 1. So doing 32 times by 1 times by 1 will get us 32. We'll have 2 to the power of 4, which is 16, multiplied by 3x to the power of 1, which is 3x, multiplied by 5c1, which is something, as a reminder, you can type into the calculator, and you get 5. So multiplying those things together, you'll get, what will you get? That's not a particularly nice number, 240x. And then continuing on, we're going to do 2 to the power of 3, which is 8. We're going to have 3x squared. Now be really careful. A reminder that by index laws, 3x all squared in brackets is 3 squared x squared, which is 9x squared. And then we're going to multiply that by 5c2, which if you type into a calculator is 10. So therefore, multiplying all that together, you'll get 720x squared. And then we're going to do 2 squared, which is 4, times by 3x all cubed, which means we got to cube the 3 and cube the x, which is 27x cubed. And then multiplying that by 5c3, which is 10. So therefore, if we multiply that stuff together, you'll get 1080 x cubed. And then 2 to the power 1 is, of course, just 2. 3x to the power 4 is going to be 3 to the power 4, x to the power 4, which is 81 x to the power 4. And 5c4 is just 5. So then, therefore, that will get us 810 x to the power 4. And then lastly, 2 to the power 0 is 1. 3x to the power 5 is 3 to the power 5 x to the power 5, which is 243 x to the power 5, getting pretty big now. And then 5c5 is luckily just 1. So therefore, the final term in the expansion is 243 x to the power 5. However, we've now found all the terms, but this isn't how I'd write the final answer, because I've written all the individual terms as just completely separate things. Whereas in reality, when you multiply out brackets, such as for instance for this example, 2 plus 3x to the power 5, what would happen is you'd write all the terms added together. So the final answer to this binomial expansion is 32 plus 240x plus 720x squared plus 1080x cubed, plus 810x to the power 4 plus 243x to the power 5. And that is our first binomial expansion example done. However, as I pointed out, I set out this stuff using a table, but some people don't like to do it that way. They like to write it in a more formal way, and so therefore I will show you that way of doing it. Personally, I don't like this way of doing it as much because it's more difficult to spot a silly mistake, but it is the more official way of writing it out, so that's why some people do write it out this way. As I said though, it is just writing out all the same stuff that you write in the table, but just writing it all together in one big go. So therefore we have the NCR part for each term. You're then multiplying that by the 2 to the power of something, which starts off at the highest power it can be. Meanwhile, the other thing, the 3x in this case, is taken to the lowest power it can be. And then as we progress along, of course, the R part of NCR increases by 1, the power of the 2 decreases by 1, and the 3x power increases by 1. So it is the same thing, just presented in a slightly different way. Another disadvantage of this stuff is you're more likely to run out of room when writing this stuff out horizontally, so therefore you might have to spill over into a second line like I am now. Maybe I could have fitted in more terms, but I knew I was going to have to spill over eventually, so I may as well do it now, so I don't just have one random term isolated by itself. So lastly, 5c5, lots of 2 to the power of 0, lots of 3x to the power of 5. Cool! As you can see, we're just then calculating each of these parts by multiplying all those 3 parts for each term together, and you'll get the exact same answer we had before, so I'm not going to continue on from that stage, because it's just this initial stage that looks different. But now that we've done that, there's a second example I want to show you, because you do have to watch out for situations where there's a minus sign inside the brackets, because you do have to take account of that. Once again, I'm going to use the table, and therefore once again the first column in the table is going to be the A thing. Whatever you want to decide as your A, I'm going to decide the 4 is my A. So I'm going to start off as 4 being taken to the power of 3, in other words the power of the brackets, and then as each term progresses, we're taking that to a smaller and smaller power. Meanwhile, the other thing is going to be taken to increasing powers as we go down. But watch out, the B term is not just going to be 5x, it's going to be minus 5x. That's really important because the minus sign is also going to be taken into account when we're applying the powers. So we're going to start off with minus 5x to the power of 0, but then we're going to do minus 5x to the power of 1, minus 5x to the power of 2, and then minus 5x to the power of 3. And then lastly, as always, we have the NCR part, which will be always 3c something because the power of the brackets is 3, and then we're going to start off with 3c0, 3c1, 3c2, 3c3. So calculating all of these things, 4 cubed is 64, 4 squared is 16, 4 to the power of 1 is 4, and 4 to the power of 0 is 1. But watch out, minus 5x to the power of 0 is just 1, because anything other than 0 to the power of 0 is 1. Minus 5x to the power of 1 is just minus 5x. But really, really watch out when it comes to minus 5x all squared. Reminder, that's minus 5 in brackets squared times by x squared. And minus 5 times by minus 5 is positive 25. So we have positive 25x squared when we do minus 5x all squared. But minus 5x all cubed is going to be minus 5 cubed x cubed, and minus 5 cubed is minus 125x cubed. Watch out, a minus number cubed will become negative again, and in fact what you're expecting to see is this positive, negative effect happening if you've got one of the things being a negative thing like we had. So that's something to bear in mind. And then lastly, the NCR, so 3C0 is just 1, 3C1 is 3, 3C2 is 3, and 3C3 is 1. Just, you can find all those values by typing them into the calculator. And then all we've got to do is, of course, multiply each of these parts together to get each term. But to save a bit of writing out, I'm just going to launch straight from that bit to the final stage. So 4 minus 5x to the power of 3 is just going to be 64 times by 1, which is 64. Then we're going to add on what we get from the next term. However, watch out, because we're doing 16, a positive thing, times by minus 5x, a negative thing, times by positive 3, that means we know the second term is going to be a negative thing. So instead of adding a negative thing, I'm just going to take away something because that's easier to write. So therefore we've got 16 times by minus 5x times by 3. If you multiply all of that together, you will get 240, or minus 240x to be precise. So therefore that's what I'm going to write there. We've got 4 now multiplied by positive 25x squared times by positive 3. So we're going to get a positive 300x squared from doing that. And then lastly, we're going to have 1 times by negative 125x cubed times by 1. So that's minus 125x cubed on the end. So there you go. That's the answer to the second example. But once again, reiterating, be really careful with those minus signs, particularly as you've also got to be aware, a reminder of dealing with that index law. Something times by something else to a power means you end up having to take both those things to the individual power. Okay, that will do us for today. However, in a future video, I will be talking about some extra details to watch out for when doing binomial expansion when it comes to exam questions. So do stay tuned for that video, but for now, it's goodbye.